Hello everybody, welcome back. Today we're doing chapter 4, oblique triangle trigonometry. So we're going to look at all different types of triangles. We're going to look at acute triangles, right angle triangles, and of course obtuse triangles, which would be the focus of this chapter. Some of the big ideas: we're going to use the sine law to determine side lengths and angles in obtuse triangles. We're also going to use the cosine law to determine side lengths and angle measures in obtuse triangles. And of course, we're going to solve word problems using obtuse triangles. Today we're going to start with 4.1. Let's look at some of the properties we have of a obtuse triangle. So first of all, like I mentioned before, let's look at right angle triangles. Just a little reminder, because sometimes you'll be dealing with right angle triangles. Remember, the focus for the sine and cos, of course, are tangent as well. We all know tangent is opposite over adjacent. But remember, these only can be used for a right angle triangle. Okay? And again, of course, you can use the tan as well when needed. And I guess I'll enter that in there just to have. So the tan is opposite over adjacent as well. Okay. Again, only in right triangles. When we have acute triangles, the sine law and cosines, the cosine law have been used for acute triangles. Again, these are two different ways we can express the formula in the sine law. The first one here is when we know a side length, when we're looking for a side length and we know the angle, and of course a pair. And we use this with the sine the reciprocal essentially, when we are looking for the angle. And again, there are your cosine formulas that we used in chapter 3 as well. I can rewrite the ones for cosine A if you're looking for the angle as well. I'll do that like I did in chapter 3 as well. Okay. So what's new here today is in obtuse triangles, the sine law and cosine law can also be used for obtuse angles. But we need to understand the sine and cosine values, first, though. There's an interesting occurrence here. So an obtuse angle is any angle greater than, this should be 90 degrees. My apologies for the typo. And an oblique triangle is any triangle that does not include a 90-degree angle. Okay? So a few things to remember. If you have an angle between 0 and 180 degrees, sine is never negative. So basically, sine of that angle is equal to the same sine of that angle minus 180 minus that angle. And I'll show you what that means in a little bit here. Okay? We'll look at some of the examples. If you have an angle between 90 and 180, cosine is negative. If you have between 0 and 90, cosine is positive. And if you have an angle between 90 and 180, tan is negative. And if you have an angle between 0 and 90, tan is positive. And I'm going to show you some examples of those in a little bit. So, what angle would give the same ratio or answer as sine of 17? So if I take sine of 17 on my calculator, okay, sine of 17, so I show my calculators in degrees. I take the sine of 17 degrees, and I get 0.29. Well, if you look back at your notes, it says the sine of any angle is equal to the sine of 180 minus that angle. So I'll put that in. So that would be the same as sine of 180 minus that angle, theta, 17, or 163. Right? Sine of 163, just to show that it's the same. That's 180 minus 17. They're all equal. Now, we're going to furthermore explore this in Pre-Cal 11 and Pre-Cal 12, but there's an interesting thing happening here. And again, we're going to talk briefly about it a little later on in the chapter. Talk a little more about that, but it's interesting. Okay, but we're going to learn why, like I said, in some of the later courses. Okay. So what angle would that be? If I just take this to answer this question. So sine of 17. Degrees is equal to the sine of 180 minus 17 degrees, which is equal to the sine of 163 degrees, which is equal to, well, we just did it on our calculator, 0.29, 4 places after decimal fine, 29237, and so on. 5 places doesn't make a difference. So that would be the angle that would give the same. So cosine 45 would be equal to minus cosine. So this is false. Okay, and we can show you that in the calculator because remember it has to be negative up here. Which is between 0 and that, right? So let's take a look. Just to prove that. So the cos of 45 is positive 0.7071, and the cos of 135 is equal to negative 0.7071. Again, we're going to learn about why that is. All right, but we're just exploring this for now. True or false? The negative tan 23 degrees is equal to cos 157 degrees. So that would be this scenario here. Let's check it out. So negative, and make your prediction. Negative tan 23 is negative 0.424. And then we're doing tan 157. And that's also equal to negative. So that would be true. And we know this one is going to be true. 180 minus that, first scenario here. Double check it. Sine 37. And sine 133. Oh, no, it was different. Oh, yeah, they only add up to 170. Oh, see, I almost got you there, right? Quick look and said, oh, yeah, no. But that would have to be 143, or that would have to be 47. So, double check it, right? So, it's actually false. Okay. Next one, if sine theta is equal to 0.14, what are the all positive values? Well, first we'll do it on the calculator. So we take our theta. And that's equal to the inverse sine of 0.14. The brackets, your calculator will give you the brackets. Solve that and see what we get. So we go to our calculator. Second function, sine of 0.14, close your brackets. Oh, sorry, second function, sine of 0.14, that's better. We get 8.047, so 8.05, or just 8 degrees. Equals 8 degrees. Sorry about that. 8 degrees. Now, what else would give us that? Approximately 0.14, and again, it's going to be a little off. Well, if you said, if you try the sine of 172, let's check it. So the sine of 172, so we take the sine, take the sine, and 72 degrees, See what you get. Sine of 172. And we get the same thing. If we round that, 2 places would be 0.14. 9, right? Which would round to, so we have 2 places after decimal in the original, it would be 1.04. Right? And those are the possibilities. There are more values, but between 0 and 180, that's will give you a positive 0.14, which is right here. This scenario right here, sine is never negative between 0. And we're going to learn why, like I said, when we get to some of the later grades, or later courses, I guess I should say, in Math 11 and in Math 12, in some of your pre-calculus courses. Last one here, cos. We're going to sign all the values we get there to give us 0.65, so we're going to do the same thing. I'm just going to steal all this, and I'm going to use cos instead, so just bear with me, just so it'll save me some typing. Cos, 0.65, 0.65. That's going to be cos, and that's going to be cos, and I'll change that angle in a minute. So what do we get here? We take the inverse cos, second function cos, 0.65 or 0.65, and we get 49.6 degrees, 49.6 degrees. 6 degrees. Okay. Last one I left at decimal 0 because it was pretty close anyway. So if I take the cos of 180 minus that, right? So it would be 130.4 degrees. We know that that'll actually give us the negative of this, right? Because if you look up here, you get the negative of it. So you'll never get the positive value here. So this is actually the only possible answer. And I'm going to show you why. I'm going to do it just to show you. Make sure we got it. And cosine of 1, and we're just taking 180 subtracting 49, right? And it gives me 130.5. And I get the negative 0.65, right? So I get negative, well that should be a 5, sorry. My apologies, it should be a 5. Not that it makes a whole lot of difference, but I'll fix that. And remember, that gives us negative 0.649, which would be negative 0.65. So that's not it. So this is the only possible answer right here. Okay? So let's just exploring our calculators, exploring sine and cos past 90 degrees, because that's what we're going to be dealing with oblique triangles and obtuse angles. Okay? So this is your homework. Homework, just a few more questions just to try on page 163, numbers 1 through 4. Hope you're liking the videos, and we'll see you again soon in 4.2 when we look at applying the sine and cos lines for obtuse triangles. Thanks everybody for watching. We'll talk again soon.